Today on the Idiot's Guide, we're talking about the story of one of the most electrifying inventions of all time, the battery. Now imagine your life without it. No smartphones, no electric vehicles, no backup power for emergencies. Batteries are everywhere, powering the devices and systems that define modern living. But where did it all begin? And how did we go from Alessandro Volta's early experiments with frogs to today's high-capacity lithium-ion batteries? In this episode, we'll explore the invention of the battery, its evolution over time, and how this unassuming innovation has transformed society. So plug in, let's get charged. I'm your host, Adam Richardson, aka The Profit Hacker, and I'm joined by the man in charge, Mr. Joe Haslett. Welcome to the Idiot's Guide. So, a lot of what I guess I was thinking about the scope of this episode and the scope of batteries in our society and about everything that batteries goes into. And I have to say that the inventor of the battery has it's surprising to me how few people actually know, because this dude, more than the light bulb, this is the reason the light bulb can even exist in the first place. The generation of electricity is ultimately what you're talking about here, because a battery in and of itself is a self-contained generator of an electricity. Ultimately, that's what it was.
Or a holder of an electrical charge.
Okay, that's fair. But in the sense of how it creates the electricity, that's essentially the original development of the battery, or the existence of it, or what they call the voltaic pile. So 1800, beginning of the 1800s, is really that first true battery, and essentially the voltaic pile is what's called. Basically, it's this alternating discs. So it's zinc and copper alternating, and or other metals if you had, but separated by a cloth material, and then soaked or paper that's soaked in salt water. And then essentially, as that's going through, because of the contending metals that you're working with and the saltwater solution, I don't know the elemental compound that would basically, in that point, generate electricity. Do you? But it creates an electrical current.
The NaCl, this sodium chloride that's in the water.
Yeah.
So I'm not going to go into how electricity works. But essentially, the reason the salt water and all that stuff works is because you have free electrons that, because of the differing metals, they're doing a pull and a push of those electrons that are freely moving through the salt water. And then you get into a lot of that, again, I'm not going to go into how electricity works in a battery, but that's the idea, is that you are pushing the electrons through, and the movement of the electrons is electricity.
Okay.
And so that's when you've got those free electrons from the salt water, that is then what is creating that move, or capable of taking those electrons and moving it through this, I don't want to say opposing metal, but because opposing would be more magnetic features, but it's moving it through the different metal plates.
Okay. But I'm assuming the atomic makeup of each metal helps with some level of why it's conducting electricity.
So you have to have certain metals. Not any metal will work with this. And that's because
I got this tinfoil that's Reynolds and this one from Kroger, and it's not working.
It's because of the way that the metal is interacting with those, with the release of the electrons and the attraction and why can't I think of the opposite of attraction?
I just think about when opposites attract.
There you go.
I don't know why, but that's where I went.
That moves the electrons through it, and the movement of the electrons is the electricity.
Okay. Essentially, and so what happened with the voltaic pile is they connected a wire to it and found it flowed a current through that wire.
Yep.
What's interesting is that as I was doing a little bit of research on this, they originally, before kind of this, earlier experiments of development of electricity, just the current of electricity, where they'd use frog legs, frog parts, and they would connect them through different like series points and then run like a vinegar-based solution over it. And they believed that electricity at this time was being developed because of the muscular makeup of the frog legs, and that's why it was doing that, which is not. It would, but that's essentially the earlier formation of like how they were trying to find electricity, is that in nature there's a level of electrical current flowing through, at this point, frog legs. I don't know. Like
now we credit him as the developer of the battery. Unfortunately, there are a lot of evidences in history that, as is usually the case in the East, they discovered these things long before we discovered it in the West and had been using it for a long time. So in clay pots, they had different metals and different liquids, and they were able to generate a very, very small but a voltage through those pots. And they believe those were the original batteries.
I'm curious what they were powering.
They don't know.
Cell phones,
there was
chargers?
Yes. It was the time traveler going back. He needed to power up his cell phone.
I think I can make a voltaic pile by...
Yeah. And so there's actually a really great Mythbusters episode on this in the early Mythbusters where they try to recreate the technology. But that was more realistically probably the first development. It just never made it into mainstream technology to be used across the globe. And so it's these, like we talked about last time with, the great marketing capacity, that's what makes technology usable. Not the technology itself, the marketability of it.
Yeah. And I think what's interesting is like this was a foundational piece to like the development of electricity in general, giving the ability to have scientific experiments, and really a lot of other electric discoveries that are in our history, much like the telegraph. On our next episode, we'll go into a lot more detail about the telegraph and its evolution from there, but or even in the sense of earlier motor vehicles. And to this day, all motor vehicles have to have a battery. Yep. Even electric vehicles are batteries. So batteries have been an essential ingredient in pretty much everything in our modern history's development. So
even things that run on electricity. So even though our camera here is plugged in, there is still a battery in that camera.
Yep.
Everything that we use has some kind of battery. Even when we talk about solar power, solar farms, we are not just directly getting the power into the solar panels and then that goes directly out. What they're doing with that is they're taking that electricity and putting it into batteries for use later. When we have power plants, anything like this, they are putting that into batteries so that when there are surge times, when there's a greater need for it, they can't just, they do, but they can't just immediately increase the capacity of what they're doing, how much coal they're burning, how much whatever they're doing is being done. They take all that and they put it into batteries. Mm-hmm. And that way it keeps it stable. Otherwise, you've got huge spikes in energy output and then huge troughs in energy output. And that is inefficient. And you can't use that. And so that's why when you talk about, the ability to use this, and the movement forward for any technology, batteries are necessary in order to balance the usage of the electricity for everyday use.
one of the things as far as this, like the impact of batteries on our society is really revolutionized basically anything with electrical current in it, and also giving way or leading the way to a lot of portable energy sources, that kind of stuff, where we're looking at, oh man, the size of batteries is impressive to me. To think about like the tiniest little pill-sized battery that will last in devices for, a number of years before you're having to look at replacing that little dinky battery. This leading to the invention of this, the discovery of electricity, has been a big part of what really electrifies everyone's home. To walk in and turn the light switch on is credited all the way back to these early inventions. Your smoke detector in your house, just rattle off a couple things in your house that run on, battery powered, an alarm clock. A lot of them have a backup battery in them. If you plug them into the wall, if the power goes out, your alarm clock's not going to go, done. What's interesting is most electric devices, stoves, microwaves, coffee makers, usually they'll have a little tiny battery that's a backup so that it preserves the settings if there's a power outage.
Yeah, old computers used to have this. So when I was a kid, we had a Commodore 64, we had 286s, 386s, 486s. If you're a computer person, you know what I'm talking about. But within there, so we think about batteries today in like a laptop, the big bulky battery that can pop out, whatever. Yeah. They had little batteries, probably about that size. If you can see that.
We'll zoom in.
Yeah, just little tiny batteries. And I still remember all the ones that I saw on our computers were all red, but little red batteries that were sitting in there. And if you took that out, you lost everything on your computer. And so you had to make sure that battery was always good.
Well, I think on desktops, they still have that. They still have a little tiny power cell that's in there that's for that reason, so that if you have a complete destruction of power, it will supply enough and for long enough to where it'll preserve the data that's on there.
Yep. Otherwise, you lose everything.
Right.
If you do not have that electricity, you lose everything. And it's crazy to think that this little tiny battery is preserving all of that data.
Yeah.
And we would not have it without it. So even when you've got your computer plugged in all the time, everything, there is still a little battery that is maintaining the integrity of all of that information.
Yeah. And I obviously at this point, you're not talking about little tiny batteries that are powering, computers from back in the 90s, 80s, I think that's what you're talking about is the 80s. Okay.
70s,
but
80s.
You're talking larger cell elements of this because, the earlier form batteries would be something that would be a power supply for something like the telegraph. Okay.
Yeah.
And, batteries for that made sometimes those telegraph systems gave it some level of portability to it. But, you're still, it's interesting to me, and I think we'll dive a lot more in detail on the telegraph in the next episode. But this is really kind of like one of those foundational pieces that helped, catalyze the other future inventions, and still to this day continues to be that. It's a huge reliable source, and honestly, our society is pushing to move in that direction. But hey guys, if you're feeling powered up by this story, then give us a like and hit that subscribe button. It's a small charge for you, but a huge boost for this channel. So let's keep the energy flowing. You don't like that one?
Wow.
It's punny. You get to do dad jokes. I get puns.
Okay, I'll grant you that. I will grant you that.
If you don't want puns, you write it.
All right, puns are great. These puns are just awesome.
Okay, so let's talk about this evolution of the battery technology, because we've alluded to it. It's pretty much everywhere. It's prevalent in everything you can imagine, to the TV remotes that we turn on and we're really annoyed when the battery is going dead. I get that like an indicator on my Roku, and it says your battery's got this much left, and I'm like, that means my volume's not going to work, That means I won't be able to type like whatever. It doesn't matter what it is. It's just like this little basic controller. It seems devastating to me, because then I'm like, I have no idea if I have any more AAA batteries. So when this happens, I don't know what I'm going to do all weekend,
Well, see, remote control, that's just what you call kids, right? There's a remote control.
Not anymore, dude. Like, you don't have to go smack the kid and he goes over and changes the knob. There's no knob.
There's still little buttons on the bottom of the TV that you can...
I'm pretty sure I have no idea where those buttons are on my TV. I don't even know if they exist.
Maybe on some of the newer smart TVs, I don't know, but...
Oh, they exist on my TV. However, Roku is just a stick. So if you don't have the remote, you're done.
Okay, yeah, I'll grant you that. Yeah.
Okay, going back a little bit before the Roku TV remote went out of batteries. 1950 or 1850, you have lead acid batteries, revolutionizing really transportation. A lot of the vehicles when you first, I don't know, like 1850s, I don't know. You're talking about like Henry Ford in the like early 1900s. So what transportation of automobiles in 1859?
Oh, they had automobiles before Henry Ford. So what a lot of people don't realize is...
I guess you're right. So he revolutionized like the
manufacturing process.
Okay.
So his ability to mass manufacture these meant that the everyday person could then afford it. So instead of paying, money back then, we're talking about, almost 200 years. So monetary exchange is a little bit different when we're talking about dollar values. But imagine, instead of spending, $150,000 for a vehicle, which would be the average price of a vehicle, only rich people could afford that.
Fair enough.
The Model T, because it wasn't, or I think it was the Model A first, because it wasn't custom, it was manufactured in a, I use this word all the time. Anytime I'm talking about efficiency in any process, I use this phrase. What is it? It's the assembly line. Wow, brain fart there. The use of the assembly line, that you were specialized in a certain part of the manufacturing process, so you were great at that, and then it went to the next person and then the next person, instead of one person doing everything. The conveyor belt, all those kinds of things revolutionized the ability to produce these vehicles in a standard format, just drastically dropped the price. And so now you could get a vehicle for $20,000 instead of $150,000, which meant that the everyday person could now afford to buy a vehicle. It wasn't just a rich person's activity. So that was what Henry Ford really did to the automobile industry. But before then, and actually people think that these electric cars are like a brand new invention. No, electric cars were the original cars. We had electric cars, and they were actually more popular than gas-fueled cars back when cars were originally being used.
Yeah.
And so the idea that, the electric cars being something new is not the case. Electric cars were actually more popular and more prevalent back then. But with the advent of the manufacturing process and being able to mass produce, batteries and electricity wasn't as available to the everyday person. And so the internal combustion engine, which could be mass produced and mass used, became the standard format for anything. But you still had to start it.
So 1859, okay? We're gonna get
Sorry,
back.
did I go on a tangent?
We're gonna go to batteries and stay there for a little while. Maybe we'll have a motor vehicle revolution. I don't know. We'll see. Anyway, so ultimately, this has been an essential ingredient in vehicles since their inception, and you have, early automobiles, like Joe was saying, where you have even some of them were the concept of electric vehicles that were so like, but it's impossible, was absolutely probably, it could have been the more likely scenario had we not found, the combustible engine and it moving to our thinking that was an easier commodity to produce than necessarily the lead acid batteries that were being used in motors.
Again, it all goes back to marketing. So
that's true.
The big oil barons.
There's an element of capitalism in everything we're talking about. So no matter what, it is an inherent issue. Like, you will have it in everything. Doesn't matter if we're talking about toothpaste or we're talking about batteries or anything, or red dye number 7, whatever.
Read your history. And I'm not talking about like conspiracy theory history. That's crappy history. Read the real history. Read the history from, the adages, the winners write the history. Great. It's not always 100% accurate, but it still gives you an insight into what happened in the past. Read the history. Look at what happened in the past so you can understand how all this happened. We're giving you a lot of information here, which is the whole point of the Idiot's Guide, but, understanding a lot of that.
But useful.
Exactly. But yeah, so those lead acid batteries where you had, they were extremely dangerous. Lead's dangerous, acid is dangerous, but they were usable. And this was brand new technology.
Yeah.
Most new technology is extremely dangerous because we find the easiest format of it and then we refine it over time.
So then we move to a little bit more of a metallic element. You have nickel, cadmium.
Not Cadbury eggs.
Cadmium. And alkaline batteries. Really kind of getting the era of portabilities. The boom box you're holding above your head. Those kind of things. Like that's now what we're talking about. But even more so, the batteries get smaller. So now you're getting, D size batteries or AA size batteries, or, I remember the big chunky, they're not 9 volts. 9 volts are the little squares, but the big squares.
Yeah.
Remember the old flashlight batteries?
Oh yeah. No, we used those.
The big clunkies.
I think they were also 9 volts.
I think so. Yeah.
Yeah. But we used them for model rockets.
Yeah.
So
you had posts on them, so you had the ability to.
So you'd take the leads, put them on. So you'd have your rocket engine, put the leads in there, and then you attach it, turn it on, up it went.
They don't even make them anymore. Like, the closest thing you'll get to that is a pack that's like rechargeable for Power Wheels. That's it. Like, other than that, you're gonna get. But back in the day, man, I remember buying those for flashlights for camping trips because they didn't take D batteries. They took the big freaking square.
Yep.
So,
and the idea here is you've got new materials that produce the same kind of result. If you try to take around a lead acid filled container and you spill that, you run the risk of completely damaging yourself.
Well, as a mechanic, that was the issue with batteries, like up to like my first vehicle was that way. But first couple vehicles was careful, because even though I still had like, they say the battery acid. Well, the reason why your posts on your car battery corrode and they get all stuff, guys, it's still there. It's still in batteries to this day. AGM batteries, really stupid expensive batteries, are still an alternating plate battery, just like lead acid batteries are. So there's a possibility you pop a cap and that liquid gets on you, it's going to burn a hole through your pants,
Oh yeah. And so it's in a car, it's more stable because you're not walking around with this. And yes, it's still extremely dangerous, but that you've got all the handles and everything holding it in.
Unless your car does jumps, then you have a really cool car, but you probably should put a lid on that battery so it doesn't spill all over your engine.
But figuring out new metals, new liquids to be able to contain that means that now you have the same result. but it is safer to move.
Yeah.
And that's when we go to now lithium-ion batteries,
Yep.
which are, again, the same kind of methodology. It's just contained. And it is the energy exchange is much more stable unless you shoot it with a crossbow. I think that's what Mark Rober did recently on a video. Exploding a lithium-ion battery. He does weird stuff.
Really?
Yeah.
I've got to find that video. We'll link it in the description.
But yeah, so once you have more control and more safety with these, they become much more common. Same thing with electricity. When we talk about electricity and the currents that we're going through, it was extremely dangerous. But as it got safer, we have electricity and power poles going everywhere now.
Yeah.
And so that meant that now we have a much more portable, we could have them in our phones. We can literally have them in our pockets now. You know, I've got my car keys here that have a battery inside. You know, I can take this and I can pop this. And
my car's telling me right now that my battery and my key fob needs to be replaced. It's running low.
Yeah. So I have a battery just sitting in my pocket. This would be just completely unheard of 100 years ago.
I have a tiny battery on my wrist that's rechargeable. So, in my watch. So,
Yeah.
same thing.
I mean, you're walking around with, you know, power generation.
So, you know, now we move to things like solid state batteries, graphene batteries, and, you know, there's potential for what's called the nuclear diamond batteries. And I brought this up to Joe and he looked at me funny, like, yeah, right. And then he went and looked it up and it exists in a way that I did a terrible job explaining, but it exists at least at this point. So
Yeah, so they originally, I think the first one that was developed was in 2017, but it wasn't in any way usable. But just in December of last year, they have created a much more usable version of this nuclear diamond battery. So it's not even, as far as the press releases and everything, I don't even think it's a month old yet, which I'm really excited about. As I read that, I haven't
the
read
energy
too much
potential
about
is
it.
what excites me, because I'm like, that's you're talking about, like, you think of nuclear powered subs and their ability to sustain for a length of time. I don't know. This is my simpleton brain thing. Idiot guide. Okay. Idiot guide. Emphasis on the idiots. Okay. But my brain thinks that, you know, okay, a nuclear power sub has the ability to sustain power for a very, 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 very long time, okay? Independently, as opposed to go, oh, we got to come to surface to refuel. You know, no, like, that's why it's a nuclear power sub. And if you're harnessing that technology or that power source inside of a diamond, then what are you experiencing at that? What kind of energy levels? And I might be completely off and it's not even the same nuclear energy.
It's not.
Okay, whatever. I'm done.
Yeah.
This is my last episode, everyone. I have no idea why I'm even here. I have overqualified myself as an idiot.
Well, that's the whole idea. We are the idiots, guy. I mean, idiots leading idiots. But no, from what I read, I just read it really quick. So I could be slightly wrong in some of these numbers. But it has about a fifth of the power generation of a AA battery. So it doesn't come close to the power that's being, but I mean, it's a little diamond, so you wouldn't expect it to. But it has less energy generation as far as the power.
Like its output?
Yeah, its output is about a fifth of a
like you have a 9
AA
volt.
battery.
You're going to go like, okay, I don't know what the voltage on a AA is, but
1.5 volts. And this, again, I can't remember what the detail was. If you use up that battery, if you use it at its maximum charge, it would last about 24 hours off of that battery if it's fully utilized. And that's where this nuclear diamond comes in, is that little diamond, the what they're using for it is carbon-14. It will last 5,000 years. So very little output, but over a massively long time. And so put a bunch of these together, and now you've got more energy generation for a significant amount of time. And so that's the power of these nuclear diamonds, is that they will produce the energy for a long time without any corrosive chemicals, without any movement required. So normally, in order to create power, what you do is you create an electromagnetic field around something like copper, and that creates the electricity field.
So the source of power is unique to this because it's not off of the traditional thinking about how a battery is generating electricity. This is generating electricity in a unique way.
No. Okay. Yes and no.
So far, I'm striking out.
So again, I am still learning about this nuclear batteries or nuclear diamonds.
This is a hard quiz, Joe.
But from my understanding, so what happened? And what they're doing is anything that is radiating. So we talk about radiation a lot and how dangerous radiation is. Mm-hmm. Well, these lights are the light that we see is radiation.
Yeah.
So it is just visible radiation. It's light as part of that radiation spectrum. So things like X-rays are on that light spectrum. It's just they're dangerous to our bodies.
Okay.
So infrared light, X-rays, ultraviolet, all these kinds of things are microwaves. Also the same thing. They're all functions of the movement of light. It's just some are dangerous, some are not. So anything that has radiation is emitting some form of energy. These lights are emitting it in the form of visible light, whereas a microwave is emitting microwaves in order to heat up our food or sending information, if you're talking about microwave telecommunications, things like that. But what's happening is carbon-14 gives off a radioactive signal. It's radiating something. The problem with it is that radiation can be harmful if we're too close to it. And so what they've done with the diamond is they have been able to put that carbon-14 into the diamond that is radiating energy, but that's why it's so low powered, is because it's just normal radiation that doesn't generally impact anything, and we can't use it because it's so low powered. But also the radiation can be potentially harmful. And so the diamond, the structure in the diamond is able to contain the negative radioactive properties. So the part of the radiation that would harm us, but while still allowing the energy portion of the radiation to release. So I am, again, just reiterating some of the stuff that I've read. Some of this I know because of, just that's how radioactive things work. That's how radiation works. That's how light works, et cetera, et cetera, et cetera. How it works in the diamond, I don't have a full understanding of yet. I'm literally going to research this as soon as we're recording.
We'll talk about this.
But that's
update on a future episode.
That's the idea behind these these nuclear diamond batteries. Is it is emitting a radioactive charge. It is containing the negative radiation while allowing the power side of which this is how I don't know how it's working, because radiation is the power and vice versa.
Sure.
I've got to research this because I need to find out exactly how they're doing this. But it is containing the negative, allowing the energy to release. And so that's how these batteries work and why they're so low power, because they're using a generally safe radioactive element in order to make it safe to be around and not overpower, I'm assuming, the diamond's negative component. protective thing.
I think the element.
See, now I sound like an idiot.
So nuclear diamond batteries just sound really super cool, but also extremely expensive because even cubic zirconium, if they were using that, I don't know. Like I don't know if it's using that or a true diamond. Okay,
Diamonds aren't expensive.
Okay. Well, okay, whatever. So I'm not even like we're not going to Joe. Batteries. We're staying in like
Focus.
Focus.
I think we're having some ADHD problems today.
Yes, lots, tons. We chatted for an hour and a half before we hit record. So, I guess for me, it sounds really cool. The idea of using diamonds to do that, or nuclear energy sounds like that's all really kind of fascinating.
We're having huge advances in fusion technology.
But like you said, it might be a low output, but massing together a pile of them could create a better source for something.
Yeah.
So, where your AA battery now possesses a handful of these, nuclear diamonds instead of them being, a AA battery that's just a lithium ion.
Well, you talked about your Roku remote going out.
Yeah.
The idea behind these nuclear diamond batteries is that you plug one of those things into your Roku remote, that thing's going to last 5,000 years.
And it'll probably like glow like a flashlight when I need a flashlight. Just kidding. Idiot. So the whole point of all this and the development, and we're talking about like a future concept at this point, is this created the mobility of our entire society worldwide. Cars, airplanes, space exploration, none of that would happen without batteries. And then you talk about how even our consumption of information from Walkmans in the 80s and 90s, Discmans to iPods, now we have smartphones, wireless everything. And, we think, oh man, it's such a torture when I have to plug my headphones in. It's so terrible. Why can't I use Bluetooth technology? Oh, there's a delay in the audio with the Bluetooth technology when I'm watching it. Okay, we'll get rid of that. All of that is battery powered. Like, it is fascinating. And this rise of then renewable energy, where we have not just battery development, but storage devices because of those batteries. They are dual purposed, and we can look at ways to generate more power to put into that battery cell in order to make it sustain that energy for longer periods of time. Look at other energy sources, nuclear and diamonds, in order to have elongated energy sources so that we aren't having to deplete other things, other environmental elements just for our demands of our society. So there's a lot of really cool things that we could do, but also that, impact our everyday world. You think about Tesla's contribution to the innovation of electric vehicles and home energy storage systems like Powerwall. So I have solar at home. I do not have a battery on my house. I'm kind of giving money to the power company at this point. Why? Because my house generates enough solar power that it powers my house. All summer long, I don't pay a dime for my air conditioner to run constantly if I wanted it to. I could keep it 58 degrees in my house because my AC would die, but I could and not pay for it because of my solar power.
Yeah, we won't go into the environmental impacts of running an air conditioner.
Now,
even
if
with solar power.
Now, if I had my, a battery, a power wall on my house, then it's also the benefits of the fact that I have storage of power. So when I'm not using it, it's collecting there so that when I have a cloudy day or some other day that maybe my spike in power is not as great, it's still not impacting the grid. And so that's a possibility for energy independence. But right now, like you see this stuff continuing to develop, and it's just going to continue to get better and better. So before we move on, I want to talk about powering up another critical part of your life: finances. Our financial empowerment membership is designed to give you the tools, insights, and support you need to take control of your money. Whether you're just starting out or looking to supercharge your financial goals, this membership is your perfect energy source. It's a pause for effect. Check out the link in the description to join today. Okay. Terrible, terrible, terrible. One of the last things that I want to get to is, and a lot of what we've been really addressing is kind of a what if scenario. What if the battery didn't exist? What if we didn't have batteries? There wouldn't be smartphones. There wouldn't be laptops, cell phones, electric cars, reliable flashlights. Alarm clocks would be late everywhere. Clocks.
Everything runs on batteries.
Literally.
Yeah.
You name it. Hearing aids. What?
Pacemakers.
Wait, what? Everything.
The world doesn't run on Duncan. The world runs on battery.
That's the reason why I say this guy deserves a whole lot more credit than I believe he's getting, because I can say the voltaic pile, and we talk about that at the very beginning of this, but legitimately the founding father, he should be on Mount Rushmore.
More science. There should be a Mount Rushmore of scientists. I'm just saying.
Okay, all right. Maybe that's too far. Maybe you agree with my opinion on that. But either way, he's not there right now. I just think that he's not getting as much credit as I believe he could be getting. And he might have some element of capitalism involved in it. I don't know necessarily his upbringing or his level of sponsors, like our last episode, and beating up on Edison. But in this idea is to go the level of dependence that we have on batteries and the continual development and revolutionizing everything all along the way is credited to someone that nobody really knows. They think the Energizer Bunny. Is that what you're talking about? Is that no? Oh, that's not it. That's just a brand, But that's the reality. Is it's I can't remember anything past that. I just think of Pink Bunny with drum, dunk, dunk, dunk. So this has revolutionized communication. So if we didn't have a battery, smoke signals? I can't blink a flashlight. That doesn't work. I don't have batteries.
Well, I mean, you could, but it would be a lot.
It'd be a lantern with a shutter, open and close like that.
Exactly.
That's what they used to do on ships, or lighthouses,
Yeah. We have the gas lights. But yeah, I mean, it would be a different way of looking at everything.
Transportation, no space exploration.
Oh, yeah, definitely no space exploration. I mean, you think about, I've got flashlights for, emergency flashlights that I always take with me if I go camping, or I've just got them at home. But they just have a magnet and then copper coils. And so you have to charge them up. Or you've got ones where you crank. I'm not going to show you how to charge up mine because that will become a meme in and of itself. But you have to take the flashlight and you have to pass the magnet through the copper coil. Use your imagination.
Just imagine shake weight, but it's a flashlight when it's charged.
But you have to do that for a good 15 minutes in order to get the battery to be charged enough to actually use it.
Yeah.
And so it has a capacitor, but that in and of itself is a battery.
I mean, I think, no Mars exploration. We have a rover on Mars that is solar powered, charging batteries, and it goes for a number of years. It's still, I think, one just recently went offline. I can't remember if it's on the moon or on Mars, but yeah, I mean, just recently had a rover go offline.
We'd only ever able to function when there's sunlight out.
Yeah.
Or someone would have to be sitting on a bike all the time running that generator.
We still have fire, pitchforks and, the torches.
We could go back to the steam engine.
Yeah, that's true, So you have,
but yeah, that's how
coal
far
fire, but
back
it's fire.
we have to go.
Yeah.
Is the steam engine. Man. I mean, that's old technology to be able to develop that without batteries.
Yeah. I mean, it would disrupt every level of transportation that we know of to this day.
Yep.
and we would have to go back to that kind of travel.
I mean,
imagine shoveling coal into a steam engine to get to the grocery store so you could buy groceries.
Yeah. Well, I mean, think about mass transportation. You've got trams. You've got, here we have tracks. We have front runner. All of those are electricity. All of those are battery powered.
I'm going to look up at the sun and be like, what time is it? It looks about 2 p.m.
I actually know a guy, he learned how to do this, and he could just put his hand up, and he'd know exactly what time it was.
I remember watching that on Crocodile Dundee and being so impressed. I'm like, that's not true, but
it actually is a thing.
Oh, I know it's a thing.
You go off of, he
explained
it. I have no idea. I can.
You face a certain direction. You make sure, like all that stuff. You can use your shadow on the ground.
I can orienteer with the best of them, but figuring out the time of day, that's a problem for me. I mean, my best ability to manage the time of day, you take your walking stick and you stick it in the ground, and then you can track, basically making it a sundial. That's the best I can do for time tracking if I'm in the wilderness. But his ability to just put his hand up and he knows where the horizon is, sun is, whatever, and being able to tell the time is just staggering.
So, I think what's interesting is, like, if all of that stuff wasn't there, if we didn't have batteries, if they were not, all of a sudden batteries went kaput, what other technologies? Like, there's so many different things that we would have a chasm of development, or things that were revolutionized just because of this simple element.
Yeah.
I would even go as far as to say, like, if electricity existed but batteries did not, we'd still be in a tough spot.
Oh, we would,
because batteries are kind of like the storage locker for energy, the electricity that's being generated. Yep. So if you don't have something of to hold the capacity of electricity, then you are tied to wherever you are getting that electrical source from.
Yep.
And that just doesn't move our society. So
yeah, it would be a completely different world without a battery.
Yep. Even conversation wise, like I early on I talked about the telegraph. It's not necessarily I believe electricity plays a role in the telegraph, but not necessarily a battery, other than, some of the power cells that are probably within the amplifier of that telegraph system. So,
yeah,
but I think that's more radio tech than it is actually telegraph. But anyway, so ultimately, I think one of the things, maybe the absence of batteries would lead to what kind of environmental changes? Would we see the same issues that we're dealing with today? I know we talked about global warming and how it's not, the sky is not falling, but it is a realistic situation. We, just recently, California's facing some serious issues. Florida faced some serious issues that our country is getting impacted by some of these things that, maybe even 20 years ago weren't as catastrophic and now are coming in a stronger force. And so you're going, okay, I got to pay attention to this a little bit. Like, even though it's not the sky's falling, what are we doing now to mitigate that? To see, is this just kind of our humanity needs to adapt to the changes of the world naturally?
Yeah.
Or is it something that we can do about it?
Yeah.
And what if we didn't have batteries? Would that have been part of that change that would have helped it? I don't know.
Well, and there's a great thing if you look to the past in England, in London. It was I don't remember all the details, but you can look this up. There was I can't remember what it's called anymore, but there were a couple of years where in the winter, because of all of the fossil fuel usage, the coal and all those things, because they didn't have batteries, they didn't have those things to be able to control it. They were using fire, they were using very primitive stuff to be able to run everything. The smog got so bad that you were not allowed to go outside.
Yeah.
People were dying from inhaling all these toxic chemicals from the air. And that's where we trace back, we look back into the past, there was a large spike in the carbon in the air and things like that. How much that impacted, it was a small area of whatever.
When you said like coal engines, like if you're talking about that's the era you're talking about where, right now we've done, although we still have a combustion engine, that the type of fuel combustion and the emissions from that aren't as bad as coal.
They're tightly managed.
Yes, there's a little bit better mitigation about it, so that there's EPA standards that have to be met by components that are required on vehicles in order to be a combustion engine. You can't run them without it.
Imagine if we had still been using that level of coal production, and with the population increase over the last 200 years, how much worse would our environment be in if we continued to use those old style technologies? It would just be devastating.
So, then you move over to like hospitals, critical infrastructure, elements of our society. I think about like, I'd have to carry a satchel for all my money because I'm not going to have it at a bank. Banks can't keep track of it. It's going to be a vault because, there's no batteries to run the computers,
Well, banks would still keep track of it. That's what accountants are for.
That's why I'd have a satchel. I know you're an accountant, so you're partial to that, Joe, but I'd still have a satchel because satchels are cool.
Yeah, bookkeepers keep the books. They keep record of everything.
You're probably right.
That's what bank clerks used to be. They were clerks. They would keep track of everything.
How many strikes is this episode so far? This is 5, 6,
I
12?
don't know. But yes, banks would not be a problem because of things like that. The ledger book.
The abacus.
Not the abacus. That one next to it. Come on.
All right, let's take a moment to reflect on this charged journey.
Gosh.
We started with Volta's voltaic pile. And then, did I say Voltaire earlier? I think I said Voltaire.
Oh,
no? Okay. That's a different person, by the way.
Yeah.
Volta's voltaic pile. So, groundbreaking invention that sparked all of it. We traced the evolution of battery technology from lead acid to lithium ion and explored how, even the nuclear diamond batteries, but explored how these innovations reshaped our lives. And finally, we looked toward the future, where batteries are not just powering our gadgets and vehicles, but also helping us build a greener, more sustainable world, So there is potential there. Here's a thought. Batteries are more than just stored energy. They're a symbol of potential, a way to hold power until it's needed at another time. So how are you charging up for the future? Is that a cheesy question?
Very.
That's perfect. I want you to feel enriched by that, guys.
That's a dad question.
Listen here, Sonny.
How are you charging up for your future?
And here's a shiny nickel for listening.
That's the power plant worker dad that comes home. I was just thinking today, boy, how are you charging your future?
What's one way you rely on batteries that you hadn't considered before? And do you think batteries are the ultimate solution for a sustainable future? Or is there something better on the horizon that maybe you know about, but we don't know about, and we want to know about? So don't make it a conspiracy theory that we make up. Let the world know. Patent it first. Don't let Edison steal it.
Yeah, don't let Edison anywhere near.
Or someone that rhymes with dusk.
Or the modern version of Edison.
All right. Time for Jokes with Joe.
All right, here we go. Why do whales live in salt water?
I don't know.
Because pepper water would make them sneeze.
Achoo. It was like the cartoons when the guy's like stuck in the fish and all of a sudden the whale's like And the guy shoots out the water hole. All right, we have reached the end of our show for today. Thank you for listening. Thank you for watching. Don't forget to hit that like button, hit that subscribe button so you can see what all's happening all the time. Life's too short, so keep laughing and learning. And remember, idiots have way more fun.
Check your shoes.